Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Hey everyone, welcome to the Rare Earth Exchanges podcast. I'm your host, Dustin, joined by my co-host, Daniel. And today our guest is Leon Farrant, who is the CEO and co-founder of Green Lion and also American Lion. Leon has been a four-time entrepreneur from all over the industry, but Green Lion has the largest facility in North America focusing on battery critical metals refining. Did I get that right, Leon?
Yes, you did very well, Dustin. And
Perfect.
thank you very much for having me.
Thanks for being on the show. Leon, we'd love to just get a quick overview of how you got into the industry and what kind of drew your attention there.
Yeah, I mean, not in a smooth transition, I guess. However, it was very interesting. I had the good fortune after being in oil and gas for 17 years to meet my co-founder in 2019. We built up and sold a company in the oil and gas sector and was lucky enough to be invited to meet PhDs that were trying to commercialize technology. Met Dr. Reza Katal, and he told me the story about how 10 years ago, he started working in the battery refining space. Battery and battery materials is something that I found interesting, but frankly knew very little about. What I did know is that China had a huge head start. And interestingly, I read that China started investing state money into development of battery critical metals refining and recycling in 2007. So we bonded over that and we talked about it at length. He wrote his first patent in 2009, really one of the veterans of the industry, certainly outside China. But I admitted that I didn't know enough about batteries and battery material being from the chemical and petrochem industries. He explained to me like a child that I didn't need to know anything about battery materials, but he did need help scaling, engineering, and constructing small modular reactors to recycle battery material, which he'd already designed and validated at lab scale. And we needed to make a prototype and a pilot. And that's what we did together. And so it was, he's now one of my best mates, and we've been on a journey together for the last 7 years. It's been a roller coaster.
That's exciting. And it does sound like a roller coaster. And I'm sure things have picked up in recent years for business, I would imagine.
Absolutely. I mean, we designed our first plant and sold it early 2020, which Daniel, we were talking earlier, which is why we had to incorporate the company in 2020. Our mission was to create circular economies for batteries, but what we didn't know is that we were fixing a very important piece of a broken chain, offering refining capability to Western countries that were dependent on China for their battery materials, energy storage, and so I'm kind of proud of what we've achieved so far.
It's a big deal, Leon, and as we were discussing pre-show, the refining space. So for critical minerals, rare earth elements, what we write about a lot and what we caution governments that, visit our website and watch our show is that this is a mission critical bottleneck or area that the West has completely deindustrialized, completely. Where in the rare earth side, I think it's something like 95% plus is refined in China. So if we maybe talk a little bit about that, just this space, why there's so little of refining that happens in the West, and what are the forces that are driving change, and then we can kind of get into the company and your specific approach. At a high level, if you look at this space, what's going on?
Well, I think we spoke about this, and you completely understand that. And Dustin, I loved one of your previous episodes with a professor from Purdue, Dwayne. I think it was something, I forget his last name, but the weaponizing of interdependence is what they've worked on for a long time, right? And they started in 2007 saying that these lithium-ion batteries, which weren't, super widely used, but getting traction quickly, they started to collect all of them, all the waste. The rest of the world had been landfilling them for decades beyond this movement that they made. So, we've got to applaud their foresight in that they really got a head start. In 2007, they started to invest, and they allowed 5 years loss leading on these refineries, and then another 5 years, and then another 5 years, 15 years in total. And in the West, we very happily, we either landfilled it, or, you had some entrepreneurial sorts in different countries who packaged it up and then sold it to China. So we can't be blamed for making money where money is to be made. But the thing is, we're still doing it today. 20 years on, and we haven't invested in the refining capability in order to process these materials in country. We've got battery recyclers, and they exist in America, in Europe, and Australia, and we can Google and have a long list of them. The problem is what they actually create and where that material goes. They take these end-of-life batteries, so we're talking about EV batteries, iPhones, electronics, AI data centers, solar farm, but, big energy BESS systems, and they crush and shred, and they separate the plastics from the metals, and then they send that metal material called black mass, they send it to, effectively it goes to China. So, and you can't blame those recyclers, right, for making money and exporting that material, because the government allows it, and without intervention, the industry won't invest further and go up and go further downstream.
So, Leon, just a quick question. How much do you think of this black mass that you're talking about, how much of it does end up in China, if you were to guess? Maybe you
Say
already know.
90%. No, so 100% of that material goes to Asia. Some of it goes to Korea to fill. There are refineries in Korea. And then the vast majority, probably 90%, most months or even more, goes to freight forwarders that help that material get into China. Because their demand and their capacity currently is so big, they're the biggest buyers, and they pay good money for that material. Sorry, I have to pretext. Apart from what comes to American Lion in Oklahoma, we are the only at-scale and commercial refiner in America, so we buy as much as we can. But at our current capacity of only 2,000 tons, it's not a large. America produces 60 to 70,000 tons of black mass per annum, and we're scaling up as fast as we can. But of course, we need other parties that also refine in the USA, or, to scale very, very quickly in order to close that gap.
And I just have to say, congratulations, the largest refiner at scale in the United States. I mean, that's a huge accomplishment that we need to get out there, okay? Because this is what this is all about, right? We're trying to reindustrialize the U.S., Europe, Australia, wherever, right?
Yeah.
And we agree with you, by the way, Leon. The Chinese are incredibly industrious and great business people, and we don't blame them for doing what they're doing. I mean, anybody would do it. The problem is that the paradigm on our side in the West was get away from production, get to the idea economy and finance, finance, insurance, real estate, and we don't have to make things anymore. And there were even business schools that cranked out MBAs that rationalized that. right? So,
Yep.
but fast forward, here we are. And so you're at the forefront of this reindustrialization of the United States, okay, and other places. With that, let's talk about, the specific, would you say EVs are the primary uh, industry that benefits from this as this moves, or are there other industries that are end users as well that are material in terms of market size?
No, it's certainly not dependent on EVs anymore. But Daniel, our largest customers are major EV OEMs and automotive groups. But it's certainly moved away from that being the only part of the business, the sector that supports this need. To think of it in a slightly different way, the one thematic that goes across AI data centers, war, mobility, is batteries. Everything that goes to war today has battery power on it, including the inventory, even the foot, the air, the water. All elements need battery power, and those batteries, all of those batteries, and then all our all of the support for the energy transition. So everything that solar can't operate without batteries, wind
Mm-hmm.
can't operate without batteries, hydro can't operate without batteries. Obviously, EVs and mobility depends on batteries, but so does AI. AI data centers cannot operate without the stability, the grid stability, and the backup of huge energy storage systems and batteries. So what we're seeing is, I'm not sure if that was foreseen, but the control of these battery materials gives certain countries an absolute edge over America, Australia, European jurisdictions, because we rely on them for these materials.
100%, Leon. We wrote an article about this, that it's massive. So to your point, just in 2025, 80% of all incremental energy added to the United States in that year was either solar or battery-based storage power. So we're talking about the entire American energy market. I mean, incrementally, okay? So it's a massive market, and you're the tip of the arrow in terms of refining to help generate greater output. If we start to zero in on that, why is refining so hard? And as we get into, this specific facet, what are the primary types and what differentiates your company?
Yeah, I mean, obviously I'm Aussie, from Australia, and we're a huge resources country. So we know too well. We're probably one of the world leaders of digging and taking raw material and not investing in the refining, but sending that material away and then buying it back as an end product. So we know too well that refining typically, or traditional refining, takes a lot of capex, takes a lot of planning and foresight and investment, and it relies on commodity prices. So there's this capital avoidance of commodity risk that comes along with such investments. If the commodity price comes off and they've built a large refinery, they may be out in the wind. And so that's happened time and time again. And we've got this analogy right now with fuel prices. Where fuel prices are going up, and some countries are without fuel. Uniquely, Australia extracts a huge amount of oil, but there's not much refining capacity. So we have a problem over there at the moment. And the same thing will happen and is happening with critical metals. To drill deeper into that, Daniel, there's not all refining is equal. The refining that has worked for over 100 years in battery critical metals and many mining processes is solvent extraction in the hydromet space. There's obviously pyro.
Right.
Metallurgy has some benefits, but fundamentally for battery materials, you want to save the lithium. pyro isn't conducive to that. And it also has a very, very big carbon footprint comparatively. Hydrometallurgy, of course, on the other hand, we use water-based chemicals to separate and process metals. And that the tried and tested format is solvent extraction, or SX, in metals and oxide separation. The problem is that in battery materials, our high value targets are nickel and cobalt. And as you know, nickel and cobalt, are brothers, and they react at the same pH level and similar pH level. So not to go too much into the weeds, but this process, solvent extraction for battery refining, is the widest used process in China. And it is a process that has a very large minimum volume in order to earn money back on your CapEx spend and OpEx. And the reason why you need a significant minimum volume, 25,000 metric tons. So to put into perspective, a third of the US's total production needs to be done in one plant, in one asset. And the reason for that is that, you need to keep on acid washing. You need to keep on leaching these materials, this nickel and cobalt, to separate them 8 to 10 times. Process takes 80 to 100 hours in some instances. And that's no worries in China. I mean, they have the manpower, they have the CapEx was invested 20 years ago. There's no problem. Let's just fill it up. And they make good money now because they have the scale.
Right.
It doesn't work in America. And we've seen it with companies that have tried and failed. Two very large companies, one listed, competitor in our space, now Glencore, bought over by Glencore, and another company that had $1.1 billion invested and still couldn't make it work and went into Chapter 11 weeks ago. And the reason why is that these going big and trying to run a race against China in their format doesn't work. We need to find a shortcut. We need to be smarter, and the way to do that is, Green Lion and American Lion's patented technology. We go about it in a different way. We don't separate the nickel and cobalt. We remove everything else. We refine this material and we make what's called a precursor, or a PCAM, by removing all impurities and making 99.9% pure nickel, cobalt, manganese hydroxide that can be dropped back into battery production.
So, Leon, just real quick for our listeners here, can you describe what PCAM is and why that product is so significant? Can we connect some of the dots? Because I know it plays a big part in the battery technology.
Yeah, absolutely. And bridging from that last, statement, precursors are a specialty chemical rather than a separated commodity, an oxide or metal, sulfate. And why that's important is they command a higher premium than the commodities even that they contain. And that's important for our margins and to be able to stand up our unit economics. But most importantly, it's a product that is able to be dropped straight into CAM manufacturing, and that is cathode active material manufacturing or production. CAM and cathode material is the most significant part of a battery from a value perspective, and it's the most difficult thing to PCAM is the most difficult thing to make in the cathode structure, and bringing it to CAM is when they lithiate the nickel, cobalt, manganese. Lithium carbonate is the other product that we make there in Oklahoma, and it's a very, very high value, of course. I'm sure all your listeners are tracking the northward facing lithium prices. And that's what's also important to be manufacturing and producing in the US, Europe, and Australia.
Absolutely.
Fascinating. So go ahead, Dustin. I think you had a follow-up question.
So with the PCAM, the cathode, how much of that would you say makes up the battery? Is a significant amount? Right.
Yeah, well, from a value standpoint, it can be 50 to 75% of the value of the battery. And in a car, I mean, the Chinese cars now, more than half of the value of the car is of course the battery. So it's a significant portion of the value of the an EV is just this cathode material. And the reason why it's so valuable is, of course, the critical metals it contains, but it's also how that specialty chemical is produced. It's very difficult. It needs to be perfect, otherwise it doesn't hold charge. The cycle rate isn't achieved, and you don't get the performance you need out of electric vehicles or any other battery energy storage application.
That's fascinating. And honestly, probably explains why here in the United States anyway, why EVs are so expensive compared to
That
their combustion counterpart.
Yeah, I mean, we're working on bringing those prices down. Of course, the recycled material that we produce is cheaper than mining and refining that raw material. And I think in time, the prices are coming down pretty quickly, which is good for the consumer. Most importantly, though, I think, is that we create energy security or independence at a country level, at least with the material that's contained in that country. To me, it's silly to be sending that material away and then buying it back from adversaries.
Yeah, on that note, I think this is important. The patent, and I think it's Dr. Cattell or Cattell.
Yes. Yeah, my co-founder is a brilliant man.
Yes, and I think I love the story, how you came together and how you actually had to set up a company so that you could invoice somebody. That's a classical story. My goodness. Now, the patent and the process, are you all this particular method that you have developed and that's patented, is this a sort of a one of a kind approach that you then license to others? Share us a little bit more about that and how you can commercialize something like that.
Absolutely. Yeah, so, Reza, other than having 5 degrees, he's also written all 110 of our patents, and all of the approved in the US, and it's important to understand that the technology is quite unique because it's the first in the world that takes every type of lithium-ion battery chemistry in mixed batch. And so, when others developed refining or technology, it relied on manpower to separate batteries. So there's LFP batteries, lithium iron phosphate, there's NCM, nickel, cobalt, manganese, LCO, LTO, NCA. There's a whole raft of different chemistries. And to create a chemical reaction that works in a sophisticated way to remove impurities, protect high value target metals is difficult, and that's why it's taken us so long. 17 years now. But his approach is very novel, and we have been able to build our own plants. So again, it was not fast. It took us many iterations. We're on our 12th sizing of, now we're commercial scale plants, right? But we had to build 12 different scaled and sizes. And so our plant in Oklahoma is 6,000 times bigger than the first pilot that we had we actually had it in SK tests so it's not fast. You have to move slow and be careful with scale ups. Chemical reactions don't necessarily work when you jump up too quickly.
Right.
So how we commercialize in the USA, we've got a deployment next year that we're working on for Australia and some other locations. In those locations, we can own and operate, or we JV. We have a strong partner that manages supply chain or feedstock, and we own and operate because we've pre-sold. We have 2 offtake agreements, so we have all of our material sold for the next 5 to 10 years. And that's our nickel, cobalt, manganese, and our lithium carbonate. So take or pay. So all that materials can be spoken for. So we'll own and operate. But the other model where we've deployed our unit and our plant into Europe, for example, we've got another one that's just arrived in the Middle East, and we have a few more deployments on a licensing basis. So what happens there is we take our factory in a box or our modular plant, we deploy it into a gigafactory like the one that we've deployed to in Europe. That's an LFP gigafactory. We take their production waste and we have an inline solution for remanufacturing it so it can be dropped back in the front of the production process. So that's the best example of a closed loop that we've achieved. And on that basis, they pay us a bit. We construct the module, we deploy it, and then we're their partner to make sure it's optimized for the life of the machine. Like oil and gas, for 17 years, we made modules for FPSOs and different oil and gas assets, and they're built in the same way, 25 years life, but probably last a lot longer.
Wow, that's very impressive. The patents, how long what's the duration of the patents? So there's multiple patents, I believe,
Yes.
and they're staggered. Are they going out
They
into?
are staggered, and there are amendments and addition, and so we work with a very strong patent lawyer to ensure that we keep that rolling. But effectively, I think patents aren't the things that are going to protect us long term. Long term, we have to maintain our current position, which is the most widely distributed and the leader in battery recycling technology and refining. And so on a global basis, in the Western world, we aim and we are the primary technology utilized for refining battery critical metals. And the only way to really protect ourselves is to process more material than anybody else. And so if someone wants to stand up a plant, they think, okay, we could use Chinese technology and that will take 36 months. Permitting that would be very, very difficult. Or we can take Green Lion, American Lion's technology, which will be on our doorstep within 6 months and take 3 months to commission and install. Like our plant in Oklahoma took us 11 months. 5 of those months were permitting.
Wow. Wow. And if we look at one plant, like the Oklahoma plant, so the audience can get an understanding of the scale, like what are we looking at in terms of ability of output? Can one facility of this scale achieve?
So right now we're operating in 24 hours a day. It's 2,000 metric tons per annum of processing capacity. So that's about 4 to 5,000 electric vehicles, just to give you some concept. And we've built another 6,000 tons of capacity. It's already constructed, already paid for, and ready to go.
Wow.
We are in the final throes of bringing on an investor or a capital partner that allows us to scale up there in the US, and that brings us to 8,000 tons capacity. Now that's, it is the miners that listen in will say that they're tiny volumes, and compared to mining, they're correct. But it is consequential because, keeping in mind that 90% or more of these materials are refined in China, outside of China, the next biggest is 4,200 tons of capacity. Now, in the USA, within the next, 6 to 12 months, we will have 8,000. So we'll be the largest non-Chinese refiner of these battery critical metals by almost twofold, bigger than the Korean current largest. So we won't stop there, but it's not so inconsequential in the space that we're playing, because it's very nascent and it's growing, but it's about to explode.
No, I can assure you that 8,000 tons refining tons is game changing. Right now, even in China, a lot of people don't understand this, that the Chinese, they don't just have one like mega factory where they do 30,000, 40, 50,000 tons. They have a lot of micro situations because they like to fail fast. I mean, they've sort of figured out that if you're too big, problems ensue. So I think that's amazing. I mean, we've looked at some other companies that are looking at refining rare earths in the U.S. I mean, 8,000 tons is amazing, right? So basically, how many tons does I think you may have mentioned that tons does he consume? If you were going to supply the entire U.S., what would be that tonnage again?
Well, currently there's around 60 to 70,000 tons of this black mass material
Right.
that's produced and that goes offshore. So it's only a capital problem for me. We can scale to meet that US demand, but I think those recyclers, they're going to keep sending it they're going to China, right? It has to go through freight forwarders, so it doesn't go directly to China, but we all know that's where it ends up. And you absolutely can't blame them. They're not going to change until there's legislation stating, hang on, we should stop sending away these critical metals. Yes, it's in weight form, but it's easily refined. And the US is spending, and Australia and Europe is spending billions of dollars investing in mining assets and production of the same metals: lithium, nickel, cobalt, even manganese, even graphite. We make all of these, and yet sending so much of it out of the country. There is an executive order rumored to be created for the banning of this black mass, but it hasn't been signed yet. So, that they're the steps to secure energy security and the sovereignty of these critical metals for countries like the US.
100%. This is where the rubber hits the road. Exactly what you're doing, Dustin. You have a few more. I have a couple more questions, but I'd like you to jump in and mix it up a little bit.
Yeah, let's mix it up just a little bit. So, Leon, I'm curious, as CEO, you're navigating and operating plants in different countries. How do you balance all that? Different regulations, different cultures. Like, there's a lot of moving pieces there. How do you manage that? What's your day look like?
Well, AI has helped a lot, and whiskey also helps sometimes. What we sort of focus on is entering countries that have a rule of law, firstly, and that our IP. And we look for partners in each of these locations that really understand the dynamics of the supply chain, permitting, and the law. In the US, we were fortunate enough to be able to understand it because of our experience and our team's experience, mainly from the minerals, mining, and oil and gas industry, and Australia and some of these locations. For example, with countries like the European countries, but even India, Japan, Indonesia, they are closing their border, or already have. They've said black mass or battery waste is not being shipped to China anymore. It's too critical, and we must build sovereign capability and refining. And so they've made that move. So our phone is blowing up with opportunities in those locations. But in those locations, we must have a strong partner, a strong, dependable partner that understands the law, the operating regime, permitting, and of course, supply chain and flow. But we have the missing piece. So we can come with a technology that is tried and tested, is fully de-risked from a scale perspective. Because we make these Meccano-like or Lego-like factories in a box or modules, we simply stack them. If you need 2,000 tons or 20,000 tons, we have a module which is larger, which is 8,000 tons per module, and we simply apply more modules. So it's easy enough. So lots of good partners and good people, Daniel, is the answer to that. We've got a fantastic team. They work too hard, and too longer hours, but they also depend on very, very strong partnerships that we have in these countries.
A follow-up on that. So basically, you have de-risked this to the point where it's just merely a function of capital. You know exactly what the outputs are, and the economics look good, right? So if you scale up to 8,000, it's
Gets
solid.
better. Yeah,
It gets better.
absolutely. So there's efficiencies of scale, even in a modular process. The efficiencies come in. We use less manpower, for example, per metric ton as we scale. You only need one boiler. You only need one compressed air compressor. You don't need a plant manager, a warehouse manager, and a lab manager for every time you add a new module. You just need one more
Right.
operator per module. So they're very sophisticated. They're all IoT controlled. So they sit in a control room, and as you add modules, yes, you need another operator for all 3 shifts. The cost comes down, the OpEx comes down as we scale. So it is de-risked. The design is locked. We have to change it for power codes for the UK or for Europe or for America, of course. But structurally, it's the same thing that goes everywhere around the world.
And so on that note, and we have a lot of investors that come to rare earth exchanges, both the website, the YouTube. Are you on a pathway to go public? And maybe at just a high level, talk about what your trajectory is as an entity, how you will finance that.
Yeah, I'll absolutely talk about what I am allowed to
Of
without getting
course,
in
yeah.
trouble. We are running our last private round before we we take that decision. So we are running that now, and I mean it's a fairly simple funding round in that the money that we raise is directly spent on the scale up of our US plant. That's it. So we are we're looking for capital partners for that American Lion plant in the USA is the key ask. And so if there's anybody that's interested in building industrial sovereignty and capability in the US in this refining space, then we'd love to hear from them, because I bet there's real experts as well in your listener group, and they can bring more than just money.
There's no question that there's going to be corporate strategic capital interests. There will be private equity type of interest, and then there's the we know we interact with some of the biggest investment banks that obviously know a lot of people, and
Yeah.
they watch this show, and we meet with some of these folks every couple months to compare notes. And these are some of the biggest banks, in the country or in the world for that matter. It's all very exciting. I mean, first of all, kudos to what you guys have done. It's taken a long time, but it's amazing to see this. I feel like we're making some history here, that you guys are. That
Oh, thank you.
again, we set up to do this show and the platform and the marketplace about a year and a half ago, and we're seeing it unfold, and it's amazing, Leon, what you and your co-founder have done. So
I appreciate it.
amazing.
No,
Absolutely.
I appreciate it, and I love what you guys do, because there are a few out there that have a really pointed approach to understanding the economic and political flows with some of these gaps, as well as true technical capability. And so I'm an avid listener and a huge fan. So thank you for all the effort that goes in. And I said to you, Dustin, I said, what we have now is like the tip of the iceberg. Underneath was all the work and the sweat and the tears in Green Lion and American Lion. But same goes, I've now seen what goes into a podcast. It's not just the 30 minutes that goes live, right? Thank you for all the efforts.
Yeah, we appreciate that. Yeah, there's definitely a lot that goes into it. But with that, Leon, thanks for being on the show, sharing your story, sharing your business, and I guess celebrating the success you guys have seen in the last few years. It's really exciting, and we hope to see you guys scale to even bigger from here. So,
No, appreciate it.
with that said, you made a comment earlier, hoping that people will reach out for things more than just money. How can people best find you?
I think, keep it quite old school. Our website is very simple, American Lithium Ion, so LI-ION, or Green Lion, li-ion.com. You can just email me. My email is leonf@americanlion or greenlion.com. It'd be a pleasure to connect with anybody on LinkedIn or through any of those methods. Unfortunately, I'm not a social media person, so I don't have a handle to drop here, but
Hey, LinkedIn's good enough.
yeah, yeah.
Uh,
I
All
appreciate
right. Well,
everything, you having me on the show, Dustin and Daniel. It's been an
absolutely.
absolute pleasure.
Perfect. Well, we hope to have you again soon and get an update how things are going.
Thank you both.
Got it.